Welcome once again, ladies and gentlemen. It's Fraser Nation with your host, Timothy Frazier. We're out here, geometry series, and today we're going to talk about 1.3, which is used in the distance and midpoint formulas. Okay? As always, there's no skipping, there's no shortcut to success. If you want full credit on your notes, you need to write everything you see on your screen down. Okay? Let me tap the board. It's not the Promethean board, but this is the screen that you're watching this video on. If you see it on the screen, it needs to be in your notes. Anyway, today we're going to basically give you two midpoint formulas, give you vocab words, some stuff to remember. Let's remember that the student should be able to, or will be able to, calculate the length and the midpoint of giving line segments. So if I give you line segment AB, and I give you the coordinates of A and B, you'll be able to find the midpoint and the distance. Okay? Your essential question: how do you find the distance and midpoint between 2 points in the coordinate plane? Okay? So if you can't answer that at the end of this lecture, you and I need to have a conversation. Some things I want you to remember. Over here, this symbol, you got to remember, it means congruent. Okay. When we have this symbol right here with no arrows, this is line segment. X squared means x times x. Okay. So you times your base however many times you see this. So, and right here, when I say coordinate plane, okay, you guys remember this from Algebra 1. It's still axes. Here's your x-axis and your y-axis and your coordinate, so let's call the coordinate right here. Remember, we got to go left or right first, and then we got to go up and down. So x always comes first, then your y. Next card. Key vocab. Your midpoint, okay, of a line segment is when you have a line segment and the point that's right in the middle, when you put that point right there, you've created two congruent segments. So let's look at this picture right here. Line segment AB. I'm telling you that M is going to be the midpoint of line segment AB. So that means that I've split up A and B into two smaller congruent segments. How can I tell? Well, AM has a dash and MB has a dash. So that means that in this diagram, these two segments are congruent. So if AM is 5, MB, you best believe, has to be 5. Okay? The next key vocab would be segment bisector. Okay? First and foremost, let's remember, bi means two. Okay? So when I say bisector, and let's look at sect. Sect means cut. So cut segment into two. Okay? Cut segment into two. Okay? And basically this could be any geometric figure as long as it goes in between the segment at its midpoint. That's a segment bisector. Okay? So let's look at our picture. Here's line CD. Okay? Line CD is going through midpoint M. Okay? Now, being that it's midpoint M, we know that AM and MB are congruent in the first place. So if this is 15, you best believe MB has to be 15 as well. Okay? And we know that line CD is the segment bisector. Okay? So take a look at these two pictures. Make sure you get these down in your notes. Pause the video if you need to. Next card. Okay. Midpoint formula. I'm going to give you 2 points, A and B. Okay? A is going to have XY coordinate, and these ones right here is just the title. And B, I'm going to give you an XY coordinate, and these twos are just the title. The midpoint M, okay? So here's a picture right here. Let's say that this is point A, and let's say that this is point Oh, that can't be A. Let's go ahead. Let's go ahead and make that B. And let's make this A. Okay. I can tell you that using this formula right here, once you add the two X coordinates and you add the two Y coordinates, you're going to be able to find M. Okay? And finally, the distance formula. Same 2 points. If I give you A, which has these coordinates, and I give you B, which has these coordinates, take your X coordinates and subtract them. Take your Y coordinates and subtract them. And remember, they have to be in order. So that's why these numbers are here. I'm going to take the second X coordinate, subtract from the first X coordinate. I'm going to take the second Y coordinate, subtract from the first Y coordinate. And then we're going to square, okay? So order of operations. Do you guys remember order of operations? If not, let's go ahead and give Aunt Sally praise where praise is due. P E M D A S. Okay. So in the distance formula, we have to do parentheses first. Okay. So we have to do the subtraction first. Then we have to square. So we have to do our exponent second. Okay. And then we're going to add. Okay. So we're going to be able to see that in action. Next card. Okay. Got to practice. Identify the segment bisector of PQ, line segment PQ, and then find the distance between P and Q. Okay? So, this is the picture that they gave us in the book. We know that line segment PM and MQ are the same distance. Okay? So, we know that PM is 20. But we want to identify, we want to name the segment bisector first, okay? So what exactly is going in between or sharing a point with midpoint M? Well, we have a line that has only one arrow on it. So we're going to talk about ray M, N. And why did I start with M? Because M is your midpoint. If I wanted to be lazy, I would have used my symbol ray AM. Okay. So this is your segment bisector. Okay. And now we want to find the distance between P and Q. Well, in this guided practice, that's easy. Okay. Because we know that if PM is 20, what MQ got to be? I'll give you a second. Give you a second. Give you a second. Okay, that's right. It is 20. Okay. And remember, big segment is equal to the two small segments. So I'm not going to even write the equation out. If we have 20 and we have 20, the whole thing has to be 40. So write that down. PQ, the distance between P and Q, has to be 40. Okay? Next, identify the bisector, the segment bisector of PQ, line segment PQ. Once again, find the distance between P and Q. This one's going to be a little harder. Okay? Now, right here, it's not that hard to see. We have a line and we have two arrows. So this means that this is a line, but we don't have 2 points. So how do we identify this line? Well, look here. There's a letter that's next to the line that has no point. So we're going to use G, and we're going to say that the segment bisector, okay, is line, and remember we can't use the symbol when it's only one letter, line G. Okay, so that's your segment bisector. Okay, I'll be a little consistent here. So here's your segment bisector. Now, PQ. Now, I don't have any numbers right here, but I have a dash, and we know that these two line segments have to be congruent. So that means that we're going to set up an equation. So let's set up our equation. 5x minus 7 has to be equal to 14 minus 2x. Okay? We know that that's true because this has one dash, this has one dash. Now we have an algebra 1 problem. So the first thing that we're going to want to do is we want to combine like terms. Okay? When we combine like terms, we want to get our x's together and we want to get our numbers together. Now, traditionally, I always like to put my x on the left. So I'm going to combine and get rid of this negative 2x. And the inverse operation, subtract, is plus. So over here, I have 7x minus 7 equals 14. Ooh, writing blind is not easy. Okay, still combine like terms. So we're going to add 7 to both sides because we want to get rid of anything that's around our x. So cross the 7's out and you have 7x equals 21. Okay. Finally, we still want to get rid of everything from the x. So the inverse of multiply is divide. So we have our x, and our x is going to be equal to 3. Okay, and I'm done. No, I'm not done. Why? Because it said find PQ. It didn't say find x. So PQ, remember I told you, big segment equals 2 little segments. So PQ is equal to PM plus MQ. Okay? I don't know what PQ is, so I'm just going to leave that there. So I have 5x minus 7 plus 14 minus 2x. Okay? I'm going to combine like terms. Okay, so the 5x, the negative 2x, the negative 7, and the 14. Okay? So work with negative numbers. I always like to use money. Okay? So I know that 5x minus 2x, I have $5 in my pocket. You owe me $2. That means that you have $3 left. Then I have here minus 7 plus 7. You owe me $7. You have 14. So that means you have $7 left. So it's a positive 7 in your pocket. So we know that PQ is equal to 3x plus 7. Well, I know that our x is equal to 3, so I can plug that back in. So I have 3 times 3 plus 7, which is equal to 3 times 3, which is 9. So I have 9, put a little 9 right there. 9 plus 7, and 9 plus 7 is 16. Okay? So PQ is equal to 16. Questions? Questions? Another way I could have did that, if I know what x is equal to, which in this case I do, we know x is equal to 3. Could have did that another way. So let's go ahead and explore that. I know that x is equal to 3. So if I put 5 times 3 minus 7 and actually solve that out, I have 15 minus 7, which is equal to 8. Okay? Well, what do you know? If I know that PM is equal to 8, then certainly MQ must be equal to 8. And we know that 2 small segments equal to big segment. So again, we know that PQ is equal to 16. Questions? Next card. Midpoint. Okay. Midpoint really shouldn't be that much of a challenge to us. The only thing that we have to do is we have to take our 2x coordinates. In this example is 1 and 7. And we have to divide by 2. So let's go ahead and plug everything in. Okay. That's the one good thing about formulas is formulas you just plug in. So x1 is 1. x2 is 7. And then we're going to divide by 2. Likewise, take your 2y coordinates, 2 and 8, and we have to divide by 2. Okay? So I know that m is equal to, well not m is equal to, the coordinates are equal to 8 divided by 2. Okay? And 10 divided by 2. And you guys know this. This is just simple arithmetic here. M has the coordinates of 4, comma, 5. Okay? So if I were to graph at 1, 2, and 7, 8, I know that the midpoint is at coordinates 4 and 5. Okay? Next card. Distance formula. Okay? Likewise, when we say formula, this is something I need you to have memorized. Okay? Flashcards, a great memorization tool. Trying to study it for 5 minutes a day, that's also a great memorization tool. Just have this sucker memorized right here. Okay, so we're going to plug in. D equals, let's see if I can actually do this. Okay, radical. Now remember, it doesn't matter which one you pick to be x1, y1, x2, y2. It has to be consistent. So that's why I just kind of went ahead and filled it out for you. X2 is 1. Okay, minus, that minus right there. Then we're going to plug in -3. Okay, put that in parentheses so we can separate our two negatives. Squared plus y2, which is -4 plus 2. Okay, let's put a little radical in. Okay, so we know D equals, so I'm just going to put the equal sign. What you guys should have remembered is keep, change, flip. And keep the 1, and when I multiply two negatives, I know I'm supposed to get a positive. So let's put that in red, shall we? We know that we're going to keep, we're going to change, and we're going to add. Okay, so now I have here 4 squared, because 1 plus 3 is 4. And then I have -4 plus 2. You owe me $4. You have 2 in your pocket, but that means, muchacho, that you owe me $2 still. Okay? And we're going to square that. Now, a lot of students have been making this mistake when they plug in the calculator. They're just typing in -2 squared, and they're getting -4. No good. No good. Why is that no good? Well, the calculator's doing what you tell it to do. It's doing order of operations, and it's squaring the 4, then it's multiplying by negative. No. Use your parentheses when you're typing this in. So this is going to be the square root of 4 times 4, which is 16, and then -2 times -2, which is a +4. And you guys let me make that mistake. No. No good. No good. Right here. This was supposed to be a minus sign. Threw everything off. That's okay. That's okay. Let's go ahead and write this out for you. I apologize. Okay, so here's the equal sign. 1 plus 3, that's still 4 squared. And instead of a -2, this is going to be -6 squared. Okay. Okay, so here's your equal sign, and I have here 16 plus, okay, -6 times -6 is a +36. Okay. So right here, we're going to add like terms, 16 and 36, square root of 52. Okay. Now right here, I'm not really expecting you to break this down. Just plug it in the calculator, and here's an approximate sign. That's approximately 7.2. Okay? So, you have your homework, you have your assignment, you have your mission, my math soldiers. Go forward.